Hey everyone, Math 103, we're working on section 4.1 today. You're going to need two handouts. First one is properties of exponents, and the second one is 4.1 addition and subtraction of polynomials. We're going to start with properties of exponents. And this activity, we're going to learn why the properties work. We're going to start with a definition of an exponent. So first example, we're going to write 2 to the 4th in expanded form. Expanded form is where we write it just as a multiplication. So the base is 2, and it's going to appear 4 times in the multiplication. So 2 times 2 times 2 times 2. And this is the expanded form of the exponential notation. Your turn. Write 3 to the 5th in expanded form. So 3 is the base, so that's the number that appears in the multiplication. And it'll appear 5 times because the exponent is 5. So 3 times 3 times 3 times 3 times 3. So this is what we're going to use in order to figure out these properties of exponents. Next example, I'm going to do the reverse. So in order to write this in exponential form, 4 is the number being multiplied, so 4 is the base. And we'll count them up, 1, 2, 3, 4, 5, 6. We have 6 4s, so the exponent is 6. 4 to the 6th power. Your turn. Write that series of 7s there in exponent form. So 7 is the number being multiplied, so 7 is the base. And we have 8 of them. 7 to the 8th power. Now we're going to see what happens when we multiply exponentials together. And notice that the exponentials we're multiplying all have the same base. These properties only work if we have the same base. Two to the 3rd times 2 to the 5th. So first thing we're going to do is expand just like we did in the first exercises here. So 2 to the 3rd is 2 times 2 times 2. And 2 to the 5th, 5 2's multiplied. All right, now we're going to convert back to exponential form. So 2 is the base. It'll always remain the same. Base never changes. And see how many of them we have. 1, 2, 3, 4, 5, 6, 7, 8 2's. So that is 2 to the 8th. Next up, do x squared times x to the 4th power. Just a reminder, I'm not going to stop. I'm just going to keep going, so you should be pausing the video and working on these at your own pace. So x squared, that's 2x's, x to the 4th, we got 4x's. X is the base, 1, 2, 3, 4, 5, 6. So we have x to the 6th power. All right, next up, make a conjecture, that's an educated guess, about how to multiply exponentials with the same base without expanding. All right, we want to skip this step and go right from this to this, right from here to here. So how do you do that? Take a look at the pattern. Well, here we have a 2 exponent, here we have a 4 exponent, and here is 6. So how do you get a 6 out of 4 and 2? Add them together. 4 plus 2 is 6. Here, 3 and 5 gives us 8, so 3 plus 5 is 8. So add the exponents. Now we're going to complete the general formula. B to the x times b to the y. Right, we've got same base. Any two numbers can be exponents. What are we going to do? We're going to add those together. So we get b to the x plus y. Next up, power to a power. So we're going to expand 2 to the third to the fourth power. So first thing I'm going to do is just expand what's inside the parentheses. 2 to the third is 2 times 2 times 2. We're going to keep that out of our exponents. It's still to the fourth power. All right, now we've got 4 of these. So we're going to write out 4 of these things inside the parentheses. 2 times 2 times 2. 2 times 2 times 2. And so on. All right, so just using the definition of exponent. This exponent means we're multiplying this 4 times. So now we got 4 of them. Let's add them up. See how many we got. The base is going to remain 2. And we have 3, 6, 9, 12 of them. So that is 2 to the 12th power. Next up, x to the 5th power to the 3rd power. Now expanding inside the parentheses, that's x to the 5th, so 5x's multiplied. Still to the 3rd power, we're going to keep that out of our exponent. All right, now, using the definition of this exponent, we're going to write this out 3 times. So when we multiply all these out, we're still going to have x as the base. And we've got 5, 10, 15 of them. So that's x to the 15th power. All right, just like before, now we're going to do conjecture, how to write powers to powers as a single power without expanding. So we're going from this to this, 2 to the 3rd to the 4th, 2 to the 12th. All right, how do we get a 12 out of 3 and 4? The only way is to multiply. 3 times 4 gives us 12. Let's see if it works here. 5 times 3 is 15. So that works. So we multiply the exponents. So the general formula, we have b to the x to the y, and it becomes b to the x times y. Right, so there's our 2 general formulas so far. Next up, we're going to divide exponentials with the same base. First one, we got 2 to the 7th over 2 to the 3rd. All right, there's 7 2's on top and 3 2's on the bottom. Now, whenever we're multiplying, if we have the same number on top and bottom, we can cancel. So let's see what happens when we cancel here. Those cancel, that pair cancels, that pair cancels. So what we have left then is 2 times 2 times 2 times 2. That gives us 2 to the 4th power. And now do the same thing for x to the 6th over x to the 4th. Expanding, we got 6x's on top, 2 on the bottom. Cancel, 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 cancel. All those cancel, 4 on top, 4 on the bottom. That leaves us with 2x's. And as an exponent, that is x squared. All right, so now we're going to go from first step right to the last step. How do we get a 4 out of 7 and 3? How do we get a 2 out of 6 and 4? The only way to get that is to subtract the exponents. So for dividing exponents, we subtract. B to the x over b to the y is b to the x minus y. Now the mistake I see students make is mixing up these properties. One way to keep them straight is to remember that you never do the same operation as you do in the exponentials. For multiplying exponentials, we add the exponents. Power to a power, multiply the exponents. Dividing, subtract the exponents. These are some of the most important properties in algebra, and we'll be using them throughout the remainder of the course. So make sure you get these down. All right, now we're moving on to 4.1, addition and subtraction of polynomials. So first we're going to look at the definition of polynomials and look at a few different types. The first task will be to be able to classify polynomials on a couple different measures. So first thing, a monomial, it's a collection of variables and numbers and possibly exponents, and they're all multiplied together. There's no addition and subtraction within a monomial. It's all multiplication. So let's look at a few examples. Right, these are all monomials. So here we just got the number -3, that's a monomial. A single variable, that's a monomial. I've got a variable and a number multiplied together, that's a monomial. I've got a number and a couple different variables and one of them has an exponent, that's a monomial. Notice there's no addition or subtraction in any of these. Now a polynomial is a specific type of expression, and all the terms have the form some number times a variable, and that variable may have an exponent. The exponents can only be whole numbers, they can only be positive. Can't have any fractions up here, can't have any negative numbers. So take a look at the list there. We've got a list of things that are polynomials. 3x squared minus 7. Notice polynomials, poly means many, can have more than one term. So here we are going to see some addition and subtraction. And 5, just the number 5, that's a polynomial. It's of type monomial because it has one term. We've got 4x to the third minus square root of 2x squared plus pi x minus 9. Here's a wacky one. 4x to the third minus square root of 2x squared plus pi x minus 9. So all of these terms have this format. Some of them just look a little weird. So here's a standard term. Got the number, a is 4, and x to the third. Here the coefficient is actually a square root. That's fine, because this root is just a number. You can have any number here out front. We're only restricted by the exponents. The exponents themselves have to be whole numbers, positive whole numbers. But the coefficients can be anything. It can be a square root of 2. Pi can be a coefficient. Pi is just a number, 3.14, and so on. And then you got the constant term here on the end. This is actually in this format because you could write 9 as 9x to the 0 power. Recalling that anything to the 0 power is just 1. So this would just be 1, so we don't write it. What are not polynomials? Anything with square root around a variable. Square root of x. It's not a polynomial. And anything like this that would have a term like this would not be a polynomial. We've got 4x to the negative 2 power. Can't have negative exponents. Because technically you could write this, as we'll see a little bit later on, as 4 over x squared. And we can't have variables in the denominator in a polynomial. And then we've got another one with a term here, negative 2x to the pi. Now pi can be a coefficient, that's no problem, but it can't be an exponent because exponents can only be whole numbers, and pi is not a whole number. So be able to recognize what's a polynomial, what's not a polynomial. And we're also going to be classifying polynomials based on the number of terms that they have. So we've seen a few here. We've seen monomials, they all have one term. And the prefix mono means one. And there are examples throughout all sorts of different, mainly sciences, that use mono as meaning one. So monoculture, it's a culture of one type of bacteria. Mononucleosis, it's a cell with a single nucleus. Monoamine, it's a chemical compound with a single amine in it. So all those mean one. Now, a binomial has two terms. So an example of a binomial, two x squared y plus 7. Recall that the terms are separated by either addition or subtraction. So here's a term, here's a term. Two terms make it a binomial. So remember binomial, think of things like bicycle, bike with two wheels, bifocals, it's glasses with two different lenses in them. Then we can also have trinomials, three terms. So an example of that would be 9x squared plus 2x minus 8. Here we've got addition and subtraction there, so that gives us three terms. Trinomial. So think of triangle, three sides, triathlon, athletic events where you got biking, running, and swimming. So all sorts of different words have tri as a prefix. But math, talking about polynomials, it means a polynomial with three terms. So make sure you can classify polynomials based on the number of terms they have. The other way we can classify polynomials is by the degree. And we're going to start by looking at the degree of a monomial. So degrees of monomials are the exponent inside the monomial. Let's look at these monomials up here. And I'm just going to change this one a little bit. So if we look at the exponents here, let's say that one's a 2. A single x, it has an exponent of 1, we just don't write it. So this would be a degree 1 monomial. Here, the exponent is 2. So this is a degree 2 monomial. And here the exponent is 3, so we have a degree 3 monomial. Coefficient doesn't matter at all. It's only the exponent we're looking at. If we have a single variable, then just look at the exponent and there's your degree. Now when it comes to polynomials, It's the greatest degree amongst all the terms. So in this case, we've got a constant. Those are defined as being degree 0. So the 9 has degree 0. The negative 5x, that has degree 1. And over here we have 12x to the 4th power. So this monomial here has, or this term has degree 4. So we want the greatest degree amongst all the terms. So that is a degree 4 polynomial. All right, your turn number 1. Let's classify those two polynomials and state the degrees. For A, we have 2x squared minus 5, and B is just the number 4. First one, we've got two terms separated by the subtraction. The 5 is a term, 2x squared is a term. So that makes it a binomial. The degree, we have degree 0 here and degree 2 here. So this is a second degree binomial because we take the highest degree. So between 0 and 2, we're going to take 2 for the degree. Two terms makes it a binomial. All right, this one term, so it's a monomial, and every constant has degree 0. So this is a degree 0 monomial. All right, next thing you need to be able to do is write in descending order, otherwise known as descending powers. So with descending powers, it's just a customary way of writing polynomials. We start with the term with the highest degree, and then go to the term with the next highest degree, and keep going. And at the end, all the way on the right, we have the term with the lowest degree. And answers to questions involving polynomials should always be written in descending order. Let's take a look at an example. We got 3x squared minus 4x plus 5x to the third plus 9. So looking at these four terms, I want to start with the highest degree term. All right, 3 is the biggest exponent, so the degree 3 term we'll start with 5x to the third. All right, now we'll find the next highest degree. That'd be 3x squared, so plus 3x squared. Next highest is 1, so minus 4x. And then last we have the constant 9. Now there may be some polynomials that skip a degree. These were all in order. We might start with x to the 4th and then jump to x squared. That's fine as long as they go from highest to lowest. Your turn, number 2. Write in descending order. And I forgot to identify the leading coefficient. Okay, leading coefficient is the coefficient on the highest degree term. So here's the highest degree term, x to the 3rd power. We want the leading coefficient, so that's 5. So leading coefficient is 5. All right, your turn, number 2. So with this one, we're going to start with the highest exponent, 2x to the fifth. Go down to the next highest exponent. We got an exponent of 4 here, so negative 3x to the fourth. Next up, squared, so plus 4x squared. And then the constant term is last, minus 5. Leading coefficient, it's on the highest term, so that's 2. Leading coefficient is 2. Now next up, we're going to be adding and subtracting polynomials. And this is just an exercise in combining like terms. Recall that like terms are those terms that have the exact same variable part. It can't differ in any way. So x to the third and x to the fourth, those are not like terms. Even though they both have x, they have different exponents. So those are different terms. We cannot combine them. We can only combine x to the thirds with x to the thirds and x to the fourths with x to the fourths. First example. Now this notation sometimes confuses people when you first see it. Just because we have things in parentheses next to each other doesn't mean we're multiplying. This is not multiplication. This is addition. So now we're going to combine like terms. We're going to combine the x squared term with the x squared term. So 2x squared plus 1x squared. Combine them together and we get 3x squared. Now we'll combine the x terms. So we're going to do 3x plus negative 7x. That's the same as 3x minus 7x. So negative 4x. And now we'll do negative 5 plus 10. And that is 5. So 3x squared minus 4x plus 5. Your turn, number 3. All right, so let's start with combining like terms. We got 4x squared here, and these aren't matched up in order. And that's going to happen sometimes. So we just got to find the x squared term. So we're going to do 4x squared plus negative 1x squared. That's 4x squared minus x squared, so 3x squared. Next up, negative 2x plus 8. Negative 2 plus 8 is 6, so plus 6x. All right, now we'll do the numbers. 3 plus 10, 13. 3x squared plus 6x plus 13. All right, next up, we're going to look at some polynomials that have terms that do not match. Not every term will have a match. So 6x to the third power, we need to look for a match with another x to the third, but there aren't any. So that's just going to stay 6x to the third. Next up, we have an x squared term here. Nothing to combine it with, no other x squared terms anywhere, so that remains 4x squared. We do have a match on the x terms. 2x is here, plus 3 of them over here, so that's 5 total, plus 5x. Now we do negative 1 plus negative 2. That's negative 3. 6x to the third plus 4x squared plus 5x minus 3. Your turn, number 4. All right, so we'll start off with the x to the third terms. We have a match there. So 4x to the third plus 3x to the third, that's 7. X to the third. Next up, we've got no x squared terms here, but we have one here. And it's negative, so it's going to stay negative. Minus x squared. Now the x terms, just one of those, no matches over here. So that's going to remain plus 3x. Then we got negative 1 plus 8. That is 7. So 7x to the third minus x plus 3x plus 7. Now subtraction is a little trickier because we have to remember to subtract everything inside the parentheses. The mistake I see with subtraction is sometimes students will only subtract the first term inside the parentheses and then add the rest of them. But we need to subtract all of it. Now, some people like to do subtraction using a vertical method. And that could help you keep things straight. So I'm going to do both of these on this example. So we'll just subtract down in this column. Notice the line up like terms over like terms. X squared term over x squared term, x term over x term, constant over constant. And that's how you should always do the vertical method. So now we do 7 minus 4 is 3, so that's 3x squared. 3 minus 3 is 0, so no x's remain. So we'll just skip that. Negative 2 minus 2 is negative 4. So we get 3x squared minus 4. Your turn, number 5. You can use either the horizontal method or the vertical method. All right, for this one, I'm going to do the horizontal method. So 4x squared minus 3x squared. 4 minus 3 is 1. So we just have a single x squared there. Next up, negative 6x minus 4x. Negative 6 minus 4 is negative 10. So negative 10x. Next up, we're going to do 8 minus 3. That's 5. So x squared minus 10x plus 5. Now sometimes we're going to have some negative terms in that second polynomial. Keep in mind that subtracting a negative is the same as adding positive. I'm going to try the horizontal method again on this one. So what we're doing here is we're taking 2x squared minus 3x squared. 2 minus 3 is negative 1, so that gives us negative x squared. And now we're going to do 8x minus negative 5x. Subtracting a negative is like adding a positive, so this becomes 8x plus 5x, or 13x. And next we're going to do negative 7 minus negative 4. That's the same as negative 7 plus 4. Negative 7 plus 4 is negative 3. So that gives us negative x squared plus 13x minus 3. All right, your turn, number 6. Right, now subtracting, 2 minus negative 5 is the same as 2 plus 5, so that is 7x squared. X minus 4x is negative 3x. Now I got negative 7 minus negative 3, which is the same as negative 7 plus 3, which is negative 4. 7x squared minus 3x minus 4. Now sometimes we're going to have polynomials with some missing terms. And I find in this case it's especially helpful to use the vertical method and then use 0 placeholders for any missing terms. So we've got 3x to the third. There's no x squared term in the first polynomial, so I'm just going to write that as plus 0x squared plus 9x plus 7. And from that, we are going to subtract 2x to the third minus 3x squared plus 5x minus 2. Now that we've got that 0 placeholder, it helps to keep things organized. Right now we've got like terms over like terms in all the columns. 3 minus 2 is 1, so that's x to the third. 0 minus negative 3 is the same as 0 plus 3, so this is plus 3x squared. 9 minus 5 is 4, so plus 4x. And 7 minus negative 2 is the same as 7 plus 2, which is 9. So we get x to the third plus 3x squared plus 4x plus 9. Your turn, number 7. Right now we'll subtract everything down here. So you got 7 minus 0 is 7, so that's 7x to the fourth. 0 minus 4 is negative 4, so minus 4x to the third. Here we got negative 5 minus negative 3. That's the same as negative 5 plus 3. So that's minus 2x squared. We got 0 minus 4 again, so that's minus 4x. And 2 minus negative 8 is the same as 2 plus 8, which is 10. So 7x to the fourth minus 4x to the third minus 2x squared minus 4x plus 10. And that is it for this section. Hope you all have a great day.